Okay, quick video on quadratics and the zero product property. All the zero product property really says that if the products of two expressions is zero, then either one or both of the expressions is also equal to zero. Why do we care about that? Because oftentimes when we're working with quadratics, we're trying to figure out where does our function cross the x-axis. They're called the solutions or the zeros, and they're here and here in this particular case. In this case, they're here and here. They could be lots of different places. But when we're asked to solve a quadratic, what we're being asked to do is find out when is the height of the function equal to zero. That is, when does the function cross the x-axis? So it could look like this. So let's say we have x minus 5. We already factored out our function. We got x minus 5 and x minus 2. And we say, okay, we're going to set that equal to 0. Then what we're saying is this. To find the zeros, we'd use the zero product property. And we say, this x minus 5 is the first expression that we're talking about. And we say, well, when would that equal 0? Under what circumstance? Under what x value? So we just set it up as a small algebraic equation and say, when is x minus 5 equal to 0? We solve and we get x is equal to 5. And we can see that that's true, because if x is equal to 5, then 5 minus 5 is 0, and 0 times whatever this is also equal to 0, right? All right. The other thing that we would do to get the other 0 of our function is we pull this piece out, and we'd ask ourselves the same question. Sorry, this is supposed to be an x here, isn't it? And we'd ask ourselves, when is x minus 2 equal to 0? And that's when x is equal to 2. So the two solutions, given the zero product property, are x is equal to 5 or x is equal to 2. This is not a hard thing to do. So let me just show you the whole process, what this might look like as the whole process. So we're asked to find the solutions. We're asked to solve something. So your professor says to you, please solve this expression. So he or she says, solve x squared minus 7x plus 12 equals 0. We're asked to solve this. So the first thing we do is we factor this, and we get that x is equal to, first we factor, and our factors are x minus 3 and x minus 4. Hopefully you can see how I got that. Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7. So that was my factoring process. But we're asked to solve. So because we're asked to solve, we want to know, when does this function have zeros? So all I'm going to do is pull this piece down and solve it. We're going to get x minus 3 is equal to 0 is going to be our question. And our answer to that question is x is equal to 3. Do the same thing over here. When is x minus 4 equal to 0? Do a little bit of algebra and we get x is equal to 4. So here are our two solutions. And just to let you know what these solutions mean, it means that we have the point 3, 0. We have a height of 0, right? This is y is height. So we have a height of 0 here, or we have a height of 0 when x is 4. All right? Let's do one more. Let's do x squared plus 10x plus 25. Now let's not do that. Let's do 5x plus 6. We'd solve this. Start off by factoring. We get x plus 2 times x plus 3. I think that's right, isn't it? Because 2 times 3 is 6. 2 plus 3 is 5. Is equal to 0. So we're going to solve this. And we're going to pull this piece down here and set it up. X plus 2 equals 0 when x is equal to negative 2. We're just doing that little bit of algebra. And the same question over here. X plus 3 is equal to 0 when x is equal to negative 3. So our two zeros, or our two solutions, our two roots, are negative 2 and negative 3. So we're using the zero product property. What we're trying to do is figure out how can we make this expression equal 0. And then after we do that, we ask ourselves the same question here. How can we make this expression equal 0? So the zero product property. Hope this was really helpful. This is really key to being good with quadratics. So I hope that this made sense to you. If not, please let me know. And if you haven't already subscribed, please subscribe. Thanks.